All right, let's get the lesson going. Okay, so today we'll be doing on trigo equations. Okay, with a little bit of touch point on trigo identities. Okay, um at the start of the notes, you notice that we have provided you with some reference materials. I believe you should know what all of these things are. Thanks to Esther for helping to send the notes. Okay, so yep. So I believe you should know what all of these are because they are covered at the start of Trigo. Okay, some of them were also covered in Sec 2. Okay, but with some emphasis on the special angles. For those of us who don't really know how to find the special angles, okay, I think it's just more important that we know that the special angles are 30, 45, and 60. Okay, so usually what I tell my students to do is just to square the result. Okay, and then you square root it back to find the exact form of the fraction. Okay, so let's say, for example, let's do a quick example. If I find out what is cosine 30, okay, on my calculator, if I were to press cosine 30 on my calculator, I'm going to get a very long decimal. Okay, hold on. Okay, if I type cosine 30 on my calculator, I'll get 0.866025. Okay, so obviously I might not know what this number is, or I might not be able to remember what the fraction is. So I'm going to square both sides, okay, to get 3/4. Okay, so all you need to do is just press square and press equals, you get 3/4. Okay, and for you to be able to get the exact form, just mentally square root both sides. Okay, so you'll get square root 3/4. Okay, and you should be able to apply the square root to both the 3 and the 4. So I'll get square root 3/2. Yeah? Okay. You don't need to do this working. All this is just for you to, as a trick for you to be able to memorize the special angles. Okay. And hopefully after using them long enough, you should be able to know what these special angles are. Okay, and today we're going to touch a lot of four quadrants. So four quadrants, there's this thing called ASTC. I believe some of your schools teach it as all science teachers are crazy, math teachers are not. Hehe. Okay, so all science teachers are crazy. Basically, what this idea is telling you, which trigo ratio is positive in which quadrant. So in the first quadrant, okay, you see that all sine, cosine, and tangent are positive. Okay, so we have sine theta more than 0, cosine theta more than 0, tangent theta more than 0. But as you move from quadrant to quadrant, okay, there will be some ratios that will give you a negative answer. So for example, if I have sine theta that is here, where theta can be, let's say, I don't know, 150. Right? This answer will definitely be, sorry, not sine. Sine is positive. Okay, and this will be the only positive one. The other two ratios will be negative. Okay, so cosine theta will be negative and tangent theta will be negative. Okay, this is for sure. As long as the angle lies within that quadrant, okay, it will definitely follow this ASTC. Okay, so let's randomly throw a degree. Okay, let's say I want 300 degrees. Okay, and I know that this line here is 270 and this line here is 360. Yeah, of course I can label the other two. Okay, so you know where 300 lies. 300 lies in the fourth quadrant, right? Because it's between 270 and 360. It's somewhere in the middle. So I definitely know that I follow C. Okay, that means that my cosine theta will be positive. Okay, and the other two will be negative. Okay, so this is a concept that we learned at the start of Trigo. Okay, but when we do Trigo equations, you realize that we will use this concept quite a bit. Okay, because there are going to be many angles that we're going to find, not just one solution. We're going to find a variety of solutions, and to use this ASTC, we'll be able to cater for both the smaller number and the bigger number. Okay, you will understand what I'm talking about in due course. So of course we have written it out for you already. Okay, so that you are don't need to copy lah. Okay, and some simple reciprocal ratios. Okay, always look at the third alphabet. Okay, so third alphabet, third alphabet, third alphabet. Okay, it will correspond with the the first alphabet of the reciprocal. Can? Alright. Okay, and then also a long list of identities we just type out for you so that you're able to use it when you need to use. Okay, nothing complex, nothing too crazy. Okay, I know some of y'all don't really understand some of the things that are here. Okay, or some of the things that I went through in the last 10 minutes. Okay, y'all are a bit confused with some concepts. The main aim that I want to go through, the main aim that I want to achieve today is to be able to solve a trigo equation, both a basic one as well as a complicated one. Okay, and then of course later on you will see that there are some questions that deal with identities. So I want to touch on what are some of the tips that we can use to be able to solve or simplify these identities. Okay, but the main aim is really trigo equations. Okay, only equations. I'm touching that for the first 1, 2, 3, 4, 5, 6 questions. Okay, if you're fast and you feel like, okay, I want to move on, I don't really want to listen to him, then you can move on to question 7 onwards. These are other trigo questions. So you notice that I have quadrants for you all, okay, as well as some graphs. Yep, some graphs. Okay, and more proving. Okay, this one also quadrants, even though it looks like equations. Can? Okay, so it's just a comprehensive worksheet for you all to practice. Okay, I will teach trigo equations as I do the question. Okay, so if you're ready, let's just give you 10 seconds. Make sure you have your iPad, okay, or your stuff printed out. Okay, get your calculator, set your calculator to degree mode. Okay, make sure it's in degree mode. Okay, and then we will start in 10 seconds. All right. Okay, so for trigo equations, okay, the main idea is that I want to be able to simplify them into one basic equation. Okay, so the kind of like the easiest state lah, okay, the foundation state, like level 0, okay, is I need to be able to get it into one trigo ratio. Simplify to one simple trigo ratio. Okay, that's the main idea. If we don't have a simple trigo ratio, cannot solve. Okay, too difficult, too complex. So what is considered a simple trigo ratio? Okay, I want it to be of the form sine, cosine, or tangent. Okay, I want it to be one of these things. Okay, don't forget you can also convert them if you have a slightly more complex trigo ratio. Okay, if you have cotangent, you can convert to this. Okay, if you have secant, you can convert to this, and if you have cosecant, you could convert to this. So as long as we are able to get one thing equals to a number, that is where we want our starting point to be. Okay, so it can be anything in there. It can be x, okay, it can be 2x, it can be x squared, whatever. It doesn't matter to me. But at the end of the day, this must be a number. Okay, it can be positive or negative, but it just must be a number. I don't want x, I don't want variable, I just want one trigo ratio equal to one number. Okay, so let's just make sure we know that that is what we want our starting point to be. Okay, so we look at this question, 2 sine squared plus sine x minus 1. Okay, this is not a simple question or a simple ratio, right? Because of the existence of this square here, right? So, as Sec 4 students, we should be seasoned enough. The moment you see a square, you know that it has something to do with quadratic. Okay, so the next level is for us to be able to simplify into level 0, right? So we get a complex equation, right? Okay, and then we want to simplify to level 1, level 0. Okay, so complex equation, then simplify to level 0. So let's look at what our equation is. We have 2 sine square x plus sine x minus 1 equals to 0. Okay, so we know it's quadratic. I want to do something that's related to quadratic. Okay, so I will simplify this time, okay, to help us to visualize. Okay, so let y equals to sine x. Okay, I now have 2y squared plus y minus 1 equals to 0. Okay, this looks like something that's easier to solve. Okay, so if we solve for y, then later we can solve for x. Does that make sense? Okay, if we can solve for y, then later we can solve for x. Okay, so this still looks rather easy. Okay, just as a recap, there are three ways to solve this equation. Okay, in case some of you are only stuck with one way. Okay, you could use quadratic formula, which I love. Okay, you can use factorization if you are good. Okay, and then you can use completing the square, which I don't like for these kind of questions. No point spending so much time to complete the square when you don't really need it, right? You might as well just use quadratic formula if possible. Okay, so personally, I love to use quadratic formula. Okay, I will prefer that we use the quadratic formula to prevent us having to think about like, okay, multiplication frame or stuff like that. We want to go straight into solving the question. So we know that y equals to negative b plus minus square root b square minus 4ac over 2a. Now, you don't really need to press the calculator, okay? As in, like, you don't need to type this fraction into the calculator. Just go straight into your equation settings, okay? And type in 2, 1, negative 1. You should get your answer as half or negative 1 straight away. I don't need to go and type this fraction into my calculator. For what? Waste time. The teacher also don't know whether you type what, right? You might as well just go straight to the equation part. Okay, mine is slightly different from yours. Okay, the equation part, and just get the answer straight away. Okay, for some of y'all should be mode 5 to 2. Okay, so this will allow me to get my two answers, right? I get sine x equals to half or sine x equals to negative 1, right? And you notice this is what I wanted to achieve in the first place, right? This is my level 0, right? This is my level 0. So as of now, I haven't even started to solve the question yet, right? I want to be able to get my starting point. If I'm able to get my starting point, then we can apply solving the question. Okay. Of course, most of you all have already learned this, so I am not starting from the beginning. Which usually, if I start from the beginning, I will teach you how to solve this first. Okay, but you all already have learned this in schools. Okay, I believe everybody should have done at least some homework before. So I didn't want to start from here. Okay, instead I wanted to start from what a more common question is in the exam. Okay, which is to start from something that's a bit more complex. Okay, so now let's revise how we are going to solve these two questions. Okay, there's a set of rules that I use with my students to be able to help them to understand what remember the procedures. Okay, so first will be to check the range, followed by the quadrant, followed by the basic angle, followed by the answer. Okay, so I always follow this sequence. Okay, so first check my range. Okay, does my does my angle in the question fit the angle in the range? Okay, if it doesn't, then I need to make sure it fits. Okay, so how does this look like? So in this question, we're talking about 0 to 360. Yes. Okay, so we're talking about 0 to 360. I have sine x equals to negative 1 or sine x equals to a half, right? So, and I have 0, right? So let's look and see whether it matches or not, right? So this guy matches, the x here matches with this x. Okay, so this means I have settled R. This is done. Okay, now for the questions that don't, I just need to make sure that they match. Okay, next. Okay, we are looking at quadrants. Okay, so which quadrant does my angle belong in? Okay, which quadrant does my angle belong in? So this is a bit more complex because I'm dealing with two questions at once. Okay, let's just do sine x equals to half, and then we will do sine x. Okay, never mind, let's just do both at the same time now. Okay, so sine x equals to half. Right? We can say that since x is positive, since sine x is positive, okay, x lies in the first or second quadrant. Okay, because of what we learned before about ASTC, right? These two are the positive ones. Okay. Okay, let's move on a bit because I believe you're all quite familiar with this. Okay, so for basic angle, okay, we want to find the basic angle by finding the inverse of whatever fraction it is, but the positive number. Okay, so basic angle equals to sine inverse half, which is 30. All right. Now for this part, I'm going to do it a little bit differently from your school. Can you explain from the top again why only sine half? What do you mean by why only sine half? I don't really understand the question. I will come to you again, okay? Can you explain a bit more what you mean by why only sine x equals to half? Because after I solve it, after I solve the quadratic equation, I got two answers, right? Sine x is half or sine x equals to -1. So these are the two questions that I will approach lah. Okay? Okay, we will do the negative one later lah, okay? So this is the part that I do a little bit different from your schools, okay? If possible, just pay a bit more attention to this. I believe that this part will help you, okay? Think of it a bit like the tuition way lah, okay? Although some schools do it this way also. So what I will consider is I will always consider within the first circle. Okay, I'm not going to consider every circle, all the circles at the same time. I just want to consider my first circle. Sorry, my IEG. Okay, so within the first circle, what are my values of x? Okay, so in the first circle, x is 30 because it lies in the first quadrant, or 180 minus 30 because it lies in the second quadrant. So the answer will be 30 or 150. Now, what happens if I start to consider other quadrants? For example, if this was not 360, what if this number was, let's say, 500, right? Now I need to consider another circle. So after I go around one circle, 360, I can go one more round to 720. And you notice that this first circle does not encompass from 360 to 500. I am short of some angles. So I will want to do it again, right? So in 360 to 720. But I know this exceeds 500. It's fine. Okay. I just want to consider within the second circle, what is my answer? Okay. So x will be 30 plus 360, 150 plus 360. Because I'm considering the next circle already. Okay. So this is 390 and 510. Okay, so once I have considered both circles, okay, then I start to look which angles do not fit what I want, right? So I know that this fits, this fits, this fits, but this does not fit, right? So for this part only, I have three answers: 30, 150, and 390. Can. Thank you, Giselle, for answering the question for basic angle, right? So basically, you get sine inverse half. Okay. How to get sine inverse? Press calculator. Okay. Shift sine. That's how you get sine inverse. Okay. So I do this part a little bit differently from your school. Okay. It will be good to copy. Okay. Can. Let's see whether I get about like 13 thumbs up. Okay. If you can get about 13 to 15, uh then we will move on. Okay. I have 6 now. Okay. I have 8, 9, 10, 11. Numbers are going down. Okay, so 11 lah. Okay, roughly 11. The numbers have not gone up after it started dropping. Okay, cool. I'm not sure whether there are people that are offline, okay, or whether people have not finished yet. So let's give it a little bit of time for these people to copy, okay, while I answer some of the questions. How do I know there's only until 8? Can you explain why only until 390? How do you know it's only until 500? This is depending on the question. Okay, so it depends on the question's range. I could not have set 500. I could have set 1000, also can. I could have set 700, also can. It depends on the question, right? So this question is 360. I just wanted to change it to 500 so that I can explain adding one more circle. That's all. Okay, but if the question, the original question was just 360, right? Then I don't need this part. I don't need that part. Because I already consider all the angles that I need to consider. Does that make sense? Right. So only because it's 500, that's why I added a little bit more by adding one more circle. Here, I already know it's until 360. If it's until 360 and I already consider until 360, I'm done. Finish already. Okay. Later, when we move on to other questions with different ranges, maybe it'll be a bit more complicated. Okay. Then we will, maybe then you'll understand a bit more lah. Okay. Okay. Let's look at the other half. So next we have sine x equals to -1. Now there are some numbers that are a bit sian. I cannot do the exact same method that I did for whatever I did on the left. Okay, so some numbers you need to memorize a little bit, right? Okay, so what are these numbers? Okay, if it is 1, -1, or 0, you need to know what the answers are without having to press the calculator or do basic angle. Okay, so this is something that was changed, I think, a few years ago only. Okay, because MOE was like, technically it doesn't make sense for the basic angle to be 90 because the basic angle is supposed to be between 0 and 90. It doesn't make sense for you to say that the basic angle is 0. There's no angle. Or the basic angle is 90. It's not supposed to be so big. Okay, so for this, okay, we need to learn to memorize. Okay, sine x equals to -1. If I'm not wrong, the answer is 270. Okay, so x equals to 270 degrees. It's memory work. Okay, I don't know how to explain to you if why is it like that, but we can type into the calculator sine inverse, right? Sine inverse -1. Immediately the answer will come out as -90. Okay, you cannot see my okay, I don't know how to help you to see. Okay, but the answer is -90. Okay, but because it is -90 and you want it to be within the range, so you add 360 to get 270. Okay, so this is something that the school expects you to memorize. Okay, if you don't want to memorize, we could have used the calculator. Okay, sine inverse -1 is -90. But -90 doesn't fall within the range, so we put it as -90 plus 360 to get 270. Okay. Someone asked me why is 390 accepted when the range is 0 to 360. Okay, the range is 0 to 360, so I don't need to accept this. Okay, I don't need to accept. I don't even need to do it. I'm only writing it down because I wanted to tell you all what if you did until 500. Okay, if you did until 500, then you accept 390 and 510. Okay, 500 is an arbitrary number. Yeah, it's a random number. I anyhow set one. Make sense? Okay, so total I have 3 answers for this question. Okay, 30, 150, and 270. Okay, so we just need to conclude it. X equals to 30, 150, 270. That's all. Finish. Can? Okay, let's move on. Okay, I give you all maybe like 10 seconds if you need to take a photo. Okay, if you're lazy to refer back to the video later. Can? How do you know sine x equals to -1, then x equals to 270? Okay, you could look at the quadrants, right? For sine x, okay, this is 0 and this is 1 and -1. Okay, if you can memorize this, good. If you cannot memorize this, just use calculator. Can? Okay, for cosine is 1, 0, -1, 0. This is for cosine. Okay, for tangent is 0, infinity, 0, infinity. Okay, still, okay, you can use your calculator, don't need to memorize. Okay, if you memorize, it's faster. That's all. Okay, all right, let's move on. Okay, next, given that y is between 0 and 360. Okay, I think this is very boring. Okay, I would want to push you all a bit more. Okay, for those that are afraid to be pushed, just put 360 first. Okay, for those that are not afraid to be pushed, I would like to ask for a number. Can I ask for any number bigger than 360? First to reply me will get your number used. Hurry up. I would like some response so that we can move on. 720. Okay, thank you. So someone suggested to me 720. Let's not go with such a obvious number lah. Okay, let's go with like 700. Okay, some students don't see 360 or 720, they confuse already. They be like, what like that? Okay, so given that solve the following equation: 4 cosecant square equals to 7 minus cotangent square plus cotangent. Wow, looks damn cheap. Okay, but remember what our focus is, right? Our focus is to be able to get the basic trigo equation. Is this basic? No, it's super complicated, right? So how do we turn it into a basic equation, right? We need to use some things called identities, okay, which is given to us on page 3. Okay, so can you look at these identities and can you tell me which one do you think we should be using? Yep, very good. Okay, some people are replying me privately. Okay, so as long as someone reply me, okay, I will just treat it as like someone is responding. Okay, so don't need to feel shy. I will be your microphone. I will just try not to mention your name. Okay, so if you look at this here, right, you realize that there's a relationship between cosecant square and cotangent square. Okay, there's a relationship. Okay, so we can use this relationship. Cosecant square equals to 1 plus cotangent square. So let's use that in our question, right? Okay, so cosecant square is 1 plus cotangent square. Okay, so this is formula. Okay, it's given in the formula sheet. Please remember that. Okay, so let's expand. 4 plus 4 cotangent square y minus 7 plus cotangent square y minus 2 cotangent y equals to 0. Okay, so I got 5 cotangent square y minus 2 cotangent y minus 3 equals to 0. Okay, simple algebra, adding and subtracting, okay? So I won't like touch too much on it. So now we're going to let it be x, okay? Because we're using y already, so we don't use y, right? So we let the thing be x. So let cotangent y be x. Okay, so 5x squared minus 2x minus 3 is 0. Okay, then we want to use the quadratic formula like what we did just now. Okay. Okay, notice that the steps are the same. I never change, right? Okay, so therefore, cotangent y is 1 or cotangent y equals to minus 3 over 5. So this is already quite basic. It's quite easy, right? If you look at it, it's like, oh, yeah, pretty good. Okay, but it's not one of the three that I want to use, right? So I like to use sine, cosine, tangent. So now I need to convert this into sine, cosine, tangent. Okay, so I know that 1 over tangent y is 1 or 1 over tangent y is minus 3 over 5. Okay, then we can just flip both sides upside down. Don't need to cross multiply. You can just flip it upside down. Okay, so tangent y is 1 or tangent y is minus 5 over 3. Okay, so all these steps just to get these two as my starting points. Can? So for trigo equations, we want to think of it as two separate skill sets. One, can I solve? Okay, I believe most of y'all know how to solve a little bit. That's why I didn't want to treat it like from the start. Waste time, correct? I believe most of us are stuck at these kind of questions where I didn't even know that I needed to get there in the first place. Okay, now that you know that you need to get there, okay, then you can use whatever skills that you already have to solve. Okay, because you're probably like stuck, like how to start, right? Okay, so this is me teaching you how to start. Okay, quadratic, use quadratic formula. Okay, later we will do some with identities. Then don't need quadratic formula. We use the identity. Okay, okay. So can I just check maybe about 13 thumbs up? Okay, roughly like somewhere more than 1/3. Can I get 13 thumbs up? If I get 13, I can move on. Okay, if not, let's hold here for a while. But if I get like 11 again, then like, ooh, 15, very nice. 16, very nice. 17, thank you. Okay, cool, cool, cool. Okay, so I roughly have about half of y'all here. Okay, the other half, I hope y'all are like busy copying, therefore cannot press. Okay, and not like, I don't know, your com screen is on, but you are playing like Mobile Legends or something. Okay, if you are playing, either don't play, okay, or later you watch the recording lah. Can? Okay, so let's move on to solving these two equations again. Okay, I want to solve them separately. Okay, I'll solve them left to right because that's what I usually do in my exams. Okay, so we got tangent y equals to 1 and tangent y equals to minus 5 over 3. Okay, we just want to solve them. Okay, I'm going to solve them separately lah, okay, so that I don't confuse you back and forth, back and forth, back and forth. Okay, so first, we're going to check the range. Okay, so the range is 0 to y to 720. Right, so let's check. Okay, are my angles the same? Y and Y. Yes, they are okay. Okay, so because they're okay, I can move on. If they're not okay, later I adjust. Okay, Next, let's look at the quadrants. Okay, so since tangent y is positive, okay, I know that y lies in the first or third quadrant. Okay, follow the ASTC, right? Okay, next, find for basic angle. Oh, sorry. Yes, thanks to the 3 people that texted me. Yeah, we wanted the range to be 700, not 720. My bad, I remember wrong. Thanks for reminding me. 700, yeah. Thank you, thank you, thank you. Okay. Okay, so next will be my basic angle. Okay, so my basic angle will be the inverse, right? Just now we did sine inverse. So now we'll be doing tangent inverse, right? So tangent inverse, sorry, basic angle. Tangent inverse 1. Okay, and we know that the answer is going to be 45. Okay, so now we can use it to find the answer. But remember, I like to go in order, right? One circle first, then next circle. Okay, for the schools that use this, good. For the schools that don't use this, I would recommend that you learn this, okay, because it's easier for you to visualize. So in the first circle, okay, in the first circle, and only the first circle, right? I know that y is 45 or 180 plus 45. Okay, this is 180 plus 45 is because of the third quadrant. Okay, and I know this is not enough because I need to go up to 700, but now I've only considered up to 360. So I need one more circle, right? Okay, so in the next circle, 360 to 700, 20. Okay, notice that this is 720, yeah, not 700. Okay, because I want to consider the full circle first. Okay, I will reject later if I need to reject. Okay, so y will be 45 plus 360 and 225 plus 360. Okay, so it will be 405 and 585. Okay, now, so for this method, you will see that you know whether or not you need to go another circle. Do I need to go another circle? Do I need to add 360 again? Okay, answer is no, because I already considered up to 720. I've already covered my grounds already. I'm already doing up to 720. But my question only needed me to do up to 700. So we're done. Finish. Okay, so how many answers are there for this half? 1, 2, 3, 4. 4 answers. Okay, now let's try the other half. Okay, so we first we're going to take note of the range already settled already, right? Range already settled already, so it's fine. So let's take a look at quadrant. Okay, so since tangent y is negative, okay, so we know that y lies in the second or fourth quadrant. Okay, my basic angle, okay, will be tangent inverse 5 over 3. Now, I want you to take note of this. It's not negative 5 over 3, it's positive 5 over 3. Okay, why? Because basic angle is supposed to lie in the first quadrant. Okay, so because it's supposed to lie within the first quadrant, the tangent, the ratio should be positive. It shouldn't be negative. For question 3, why are there 4 answers when the range is only up to 180 degrees? Okay, I will cover that later, right? Maybe it's a typo. Okay, you never know. Right? Maybe it's supposed to be 360. Okay, so in the first quadrant, okay, I know that my angles will be oh sorry, I didn't calculate this. Right. So tangent inverse 5 over 3. Okay, 59.036. Okay, so y will be 180 minus 59.036. Okay, because it is the second quadrant, as well as 360 minus 59.036, because this is the fourth quadrant. Okay, so it's 239. Okay, or sorry, 120. What am I doing?
Using data right now. Huh? Huh? No, the Wi-Fi still not here. Using data right now.
Okay. Okay, so this is the first quadrant, first circle. So now I want to consider the second circle. Right? So I want to add 360. Okay? So it's 120.964 plus 360 and 300.964 plus 360. Okay, so it's 480 and 660. Okay, so in total, I got 8 answers. Okay, and the 8 answers, you try to write them in order. Okay, so 45, 120.1, 121, okay, 225, 301, 405, 480, no, 481, 585, 661. Okay, correct to 1 dp. When do you know to remove the negative sign and inverse a positive value? Always. You will always do it. Your basic angle must always do it for a positive number. Okay? Must always do it for a positive number. Can? I just realized if you're any of my ex-students, because I see a few names that are quite familiar here, or I see a few like short forms that are quite familiar here. If you happen to be my ex-student, just come and say hi lah after the lesson. Okay? I see quite a few, about 5. Yeah. So if you happen to be my ex-student, just come and say hi. Not now. Later. Okay, so got your answers. Any questions? Okay, sorry if it's too rainbow, okay? To me, as in like I just learn better with a colorful screen. Okay, because it helps my brain to compartmentalize what I want for each part. Okay, so it's just easier for me lah to compartmentalize. Okay, so I pardon if it's too rainbowy. Can? Okay, let's take this time to answer some questions. Okay, let's just give it maybe like 1 minute. Okay, whether or not you have any questions, just ask now. Okay, if you have no questions, we can take a short break, maybe like 1 minute. Okay, and then we will come back. Yes, I have questions. Very good. For sign -1 just now, we don't remove the negative sign, but we add 270. Okay, so for good question, good question. So for this one, sin x, right? Okay, so because this is -1, so okay, just now I told you, right? For 0, -1, and 1, okay, it's good for us to memorize, right? Ideally, what we do is to memorize the answer. Okay, but let's say, for example, you want to do it the proper way. Okay, so the basic angle here, okay, the basic angle is sine inverse 1, right? Because I asked you to inverse the positive number, right? So this is 90. The basic angle is 90. So why MOE decided to ask you to memorize instead of doing it is because they say that it's not possible for a basic angle to be 90. A basic angle must be between 0 and 90. So this doesn't make sense. Okay? But if you just want to do it, just do all. It's okay. Can? Then since it is negative, right? Right, my x lies in the third or fourth quadrant. But the thing is, right, when you talk about the third quadrant, is 180 plus 90, you get 270. You talk about the fourth quadrant, is 360 minus 90, which is also 270. This 270, right, lies in the middle. It doesn't lie in any quadrant. It's in the middle. It's smack in the middle, which is why MOE doesn't want to do that anymore. They've decided that, no, if it lies on the line, it does not lie on any quadrant. So we will not consider it as part of a quadrant. That's why I say memorize. Can? I hope that answers your question. Okay, but if your question in general is when do I want to do it for a positive or negative? Oh, no, sorry. When do I want to inverse a negative number? Answer is only if it's -1. That's the only one you do it for a negative number. Yeah. Only -1. Because -1 you are supposed to memorize. Right? Any other number, just do it for positive. Okay, I hope that answers your question. Okay. Nobody, no other questions. Okay, I took a while, so hopefully you all have been taking your break. Okay, how about this? Let's take a short break. Okay, maybe like 1-2 minutes. Okay, for those that are done, I would not suggest you do this question because I want to do it. Okay, so you go and do like question 5. Yeah, question 5. Okay, you can skip the first one if you don't want. Okay, you can just go and do the second one. Okay, use the first one to do the second one. Use it. Okay, cause the question said hence. Can? Okay, let's come back at like 10:30. Quick one. So for sine x, 0, 180, and 360, yes, it is. Quick break, ah. Okay, we're back. Okay, come, let's do question 3. Okay, show that 1 minus cosine 2a over 3 plus cosine 2a equals to sine square a over 1 plus cosine square a. Okay, so let's take a mental break, okay, away from solving first. Okay, we will solve again later. Okay, but right now we just want to go a little bit into identities. I just want to kind of help you and give you a little bit of tips into identities because I feel that a lot of us struggle with the idea of identities. Okay, so as what your school teachers usually say, we want to go from somewhere that's harder to somewhere that's easier. Okay, so some of us are not sure which one is more complex than the other. For the most part, anything that has double angle is more complex. Okay, double angle is harder than single angle. Okay, I know that there's a square there, but the square actually still quite okay because we already have a lot of formulas with a square inside. Okay, so we want to use from double angle to single angle. So, okay, it looks a bit difficult. Okay, first reminder. Okay, we cannot cross multiply. Okay, because what I'm trying to do is to show. Okay, I'm trying to show this is this. So I cannot use it and multiply across. Does that make sense? I must start from one of it. Now, some students will be like, oh, okay, then let me just cross multiply. Then in the end, I'm going to get what? 0 equals to 0. Okay, that doesn't help. Doesn't really help you. Okay, so let's start from the left. Okay, there are a few formulas that we have on the first page. I'm just going to write it here to make it simpler for us. Okay, so we know that cosine 2a is cosine square a minus sine square a. Okay, we know that it is 2 cosine square a minus 1, and we know that it's also 1 minus 2 sine square a. Okay, so these are all the formulas that are given on the first page. Okay, so our job is to use these formulas, basically. Okay, I just need to use to be able to get whatever that's on the right. That's all. Okay, so do it in a smart way. Don't go and like blah blah go and do. Okay, try to be smart about it. Okay, if you look at the fraction on the right, which formulas do you think you should use? Right? So please be smart lah. Make observations, right? You notice that there's a sign at the top, sign square at the top. So you don't go and blah blah and go and use this one lah. Make sense? Okay, use this one. Cause got here. Okay, so is this a guaranteed way to say that you're correct? No, it might not be. Okay, they might trick you, or this sine square might have come out from somewhere else. You might have gone through a different step. I don't know, right? But this is the best guess. Usually not so hard lah. Anyway, right? It's the best guess. Okay, so this one, right? Chances are I'm going to use this. Okay, chances are. Okay, so let's just try. Okay, I've not seen this question. I have, but I removed the answers and I can't remember. So I'm doing it with you also. Okay, so LHS stands for left hand side. Right, I'm starting from the left. Okay, so the left hand side, I have 1 minus cosine 2a over, sorry, this is too fat. Okay, I cannot write much, so I'm going to use a thinner pen. Okay, 1 minus cosine 2a over 3 plus cosine 2a. Can? Okay, so I'm going to use the green one for the top and the pink one for the bottom. So this is 1 minus 2 sine square a over 3 plus 2 cosine square a minus 1. Okay, so I'm going to skip some steps. I'm just going to expand and deal with the negative together. Okay, so this is 2 sine square a over 2 plus 2 cosine square a. Bruh, you're there already. Make sense? Right? It's not even that hard. Okay, so you just need to know that there are formulas that you need to use, and you just need to make the right guesses. Okay, don't go and anyhow go and jump. Can? So cancel out the 2. So, okay, I'm going to factorize for you, lah, okay? In case some of us don't really know. Okay, then I can cancel the 2's. Okay, so I will get sine square a over 1 plus cosine square a. Clear? Okay, okay. Now, hence or otherwise find the values of A for which given that it goes to 1/7. Okay, so let's expand. So we got if I want 1 minus cosine 2a over 3 plus cosine 2a equals to 1/7, right? Since we already have used that and proven that in the first part, okay, what we can do is we can use the formula, right? We want to use the formula to be able to get something that is easier for us to solve. Okay, so using the formula, I get sine square a over 1 plus cosine square a equals to 1/7, right? I mean, that's the whole point that they wanted us to use it in the first place, that they wanted us to prove it in the first place. If not, they wouldn't have done it. Okay, so I got 7 sine square a equals to 1 plus cosine square a. Okay, cross multiply. Okay, now we have reached another bypass. Now what? Right? So again, remember what our objective is. Our objective is to get a simple trigo ratio. This is obviously not simple at all, right? So because it is not simple, I need to use my identities to make it simple, right? So the very, very famous Pythagorean identity, okay, I know that okay, what am I doing? Okay, this is 1 plus 1 minus sine square a. Okay, because I know that sine square a plus cosine square a equals to 1. This is a very Pythagorean, this is a very famous Pythagorean identity. Basically, it's a squared plus b squared equals to c squared, right? So after I simplify everything, okay, so I get 8 sine square a equals to 1. 2 equals to 2. So sine square a equals to 1/4. Right? Okay. Do I have my simple ratio yet? Yes, very good. Don't have, right? I still have square. So now I need to get rid of the square, right? But I don't have quadratic formula here because I only got sine square. So just square root lah. Okay? So I will get half or negative half. I don't understand the third last to second last. Like how? Where is third last? Okay, sorry. I don't know when you send this. I just saw it. Okay, reply me, okay, as I answer. Is third last to second last here to here? Is it these two? Or is it the one before? Is it green above one line? So blue to blue, is it? Sorry, I a bit like stupid. Blue to blue, is it? Like that. Okay, so to help our friend, okay, I'm just going to just expand first, okay? So expand. So this one is 7 sine square A is 2 minus sine square A. Right? I just expand the bracket. Then I bring the sine square A over to the right. Okay, I bring this over to this side. That's how I get it. Okay, maybe if I can simplify this better for you, is 1 plus 1 minus. I just open the bracket lah, basically. Okay, so now this gives me two ratios to solve. Let me know if you're still not sure. Okay, I will explain again. So yep, now I have two. Okay, so sine A is half, or sine A is negative half. Wait, can explain how the 3 became 1 in the first two steps. Nali. Is it this? This purple to this green is me using what I did earlier here. Green, purple. I already showed that they are the same thing. Right? In the first part, I already showed that the purple box and the green box is exactly the same. So since they want me to solve purple box equals to 1/7, I can just solve green box equals to 1/7. That's what it means. So it's not 3 turn into 1. It's a lot of things change. Yeah. A lot of things change, right? But I replaced the whole purple box with the green box lah, basically. Okay? Okay, I hope that answers your question. If it doesn't, please ask me again. Okay? So here I got sine A equals to half or sine A equals to negative half, right? Okay. The question is asking for 0 to 180. 0 to 180, right? So for 0 to 180 is only within the first two quadrants, right? So I already know that this is rejected. So I don't even need to do the second part. Okay, if you want, you can do the second part, but you realize that the second part won't give you right answers. Okay, then this guy, exactly the same as what we have done just now, right? I will get, okay, I will get since sine A more than 0, right? A lies in first or second quadrant, right? Then my basic angle is sine inverse half. You get 30. So my x is 30 or 180 minus 30, which is 30 or 150. Okay, so quick one, right? I don't want to do again, but maybe I'll write a bit nicer. Okay, two answers. Can explain why reject. Wait, why is sine A equals to negative half rejected? Okay, it's rejected because the question asks for 0 to 180. Right? I already know that from 0 to 180, sine is positive. But here, sine was negative. So I reject. Okay? That is me doing like a shortcut, like a short method. If you don't understand that, you can go ahead and do it. Right? You can go ahead and like our previous question, just do two parts. Left, on the left, I do sine x equals to half. On the right, I do sine x equals to negative half. Just do. At the end of the day, I'll get 30, 150, 210, and 330. Then you realize that, I only want from 0 to 180 ma. So this 2 is wrong. Then I reject. At the end of the day, also reject. Make sense? I'm just doing it earlier because I already know sine must be positive from 0 to 180. Make sense? Okay. So it's a bit like shortcut lah. Okay, don't need to do everything. Yes. Okay, don't worry, it's not just you. Okay, it's a few questions. The girl that felt a bit paiseh, okay? Got a few asked me, not just you, okay? Everybody just paiseh to ask, so everybody just direct message me. Okay, cool. Now it's 10:48. I got time for one more question, okay? Shall we do question 4? But question 4 is a bit hard lah, okay? I might need to extend a little bit, I'm not sure, okay? I'm not going to do this, okay? I'm just going to go straight into the equations part, okay? So, hence, solve the equation for that, okay? 2 sine da da da, 3 sine da da, okay? Do I have the answer sheet for this? I can write out for y'all and upload. Can? But give me a while lah, because I also got other classes to teach, okay? Okay, so if you divide, right, you can see from here, okay, sine 2 theta minus 30 over sine 2 theta plus 30 is 3 over 2. Okay, so this is the same as just now, right? This is the same as this. So I can use this. I can use this because I already proved it in part 1. Even if part 1 you never do and you left blank, it's okay. Just use. Can? Okay, so you can see like your 2 theta is like your A and your 30 is like your B. Okay, just draw that relationship. So I know that tangent 2 theta plus 5 tangent 30 equals to 0. Okay, I'll give you a while for you to like digest this part. Okay, basically what we are doing is that we are using the part above to be able to solve the second part. Okay, so tangent 2 theta equals to negative 5 over root 3. Okay, why? Because tangent 30 equals to 1 over root 3. Okay, this is special angle. Can? Okay, so now when we look at the question, right, okay, we realize that, sorry, this is a typo, this one is theta, okay? Okay, so now you realize that the range in this case is not different, it's not the same anymore. The range is a bit different, right? So now my range, instead of negative 360 to x to 0, right? I want to times it now. Sorry, not x, to theta. Okay, because now don't match. So I need to make it match like that. Okay, I need to make it match. Once I make it match, that is me satisfying the range part. Okay, this is the first time that we are doing this range part for the whole question. Okay, I've never done it yet, so this is the first time that we're doing it. Okay, so this 2 theta is kind of annoying. I don't like it. So I'm going to change this question. Okay, I'm going to say tangent y equals to minus 5 over root 3 for negative 720 to y to 0. Okay, so now it becomes like what we did just now. Remember that that is going to be your baseline. If you can make every question look like this, you can solve every question. Because you already got the skills to solve this question. Right now, it's just how can I go from what the teacher is teaching or what the question is to what I know how to do. It's always this gap that a lot of us don't really know how to bridge. right? How to go from what the question is, where did you get -5? Bring it the minus across. Okay, tangent 30 is 1 over root 3, so 5 tangent 30 is 5 over root 3. Okay, then bring it across. Okay, okay. So let's go through the same steps that we did just now, right? So since tangent y is negative, so y lies in the second or fourth quadrant. Okay, so the basic angle, okay, is tangent inverse 5 over root 3. Okay, I'm not so smart, so I will do it on my calculator. Okay, it's 70.893. Okay, so remember, talk about first circle first. So in the first circle, okay, y will be second quadrant or fourth quadrant. Keep doing careless mistake today. Okay, so this is in the first circle, right? Then we talk about second circle. So second circle, right? Y is 109.107 plus 360. 289.107 plus 360. Okay, so it's 469.107. Oh no! Oh, sorry. I'm not even supposed to consider the circle before. I'm supposed to consider the circle after, right? Okay, so this is my fault. Sorry. Okay, so we're going to consider the circle here. I'm going to go backwards now. I'm not going to go forwards. I'm going to go backwards now. Okay, so y equals to 109.107 minus 360, 289.107 minus 360. Okay, but we're still not done, right? We still got one more circle after that. Okay, so we need to go back one more circle. Okay, very long and difficult question. What school is this? Zhonghua. Crazy. Very long and difficult. Okay, so in total, right? So always start with this. Always start with this. Once you did the first circle already, then you consider everything else. Don't reject. always reject at the end. Okay, so now I want it to be between -70 to 0. So I will reject this, accept this, accept this, accept this, accept this. Done. These are my 4 answers. Okay, so therefore, y, okay, is -70.893, -250.893, -430.893, -610.893. Okay, and then I know what deter is, because this is 2 deter, right? So just divide by 2. Okay, 35.4. Okay, a pretty long question. Okay, the answers a bit don't fit. Let me go and check whether the answers are correct. I think the answers are wrong. Okay, unless someone can spot an error for me, I think the answer is wrong. Yes, I will send this answer key for you. Okay, but I'll only do question 1 to 6 because I'm only supposed to be doing equations anyway. Yeah. Okay. Yeah, should be correct. Yep. Okay. Can. Okay. If not, thank you so much for attending today. Okay, I just want to do a quick summary before I end. Okay, so I already see that there are some people that just left. Okay, so whenever we do this kind of trigo equations questions, right, we just want to remember that we want to follow these steps, right? We want to do the range first. Does the range meet? Does the range in the question meet the range that I need? Okay, next we look at the quadrants. Okay, ASTC, which one does it lie in? Gonna find the basic angle, then we find the answer. And when we find the answer, we try to find the answer circle by circle. Always find the first circle first, then we use it to find the circle after or the circle before. Okay? Yeah. So this is the main gist of it. Okay. When we talk about trigo identities, we want to be able to try and make smart decisions, right? Try to be able to know which identity to substitute. Don't anyhow whack. Just because it's 2A doesn't mean it is always double angle. It can be addition formula. Okay, if you don't know what I'm saying, try to ask the teacher. Okay, yeah, we try to be able to decipher whether or not is what identity we are using, and this comes with experience, right? I've been seeing these questions for years, so immediately when I look at it, I know most probably it will be this. I'm not always correct. I can be wrong, right? But it's good to be able to have an idea first. Make sense? Yeah. If you don't know how to go from somewhere to somewhere, use Google Maps, right? And if you use Google Maps to go to the same place multiple times, you don't need to use Google Maps anymore. You know it by heart, right? So I just happen to already use Google Maps for this question many, many times. So I already know roughly what I'm supposed to do. Okay. So if you're interested to attend my class, okay, I teach on Thursdays at Tampines at 5:30. I repeat, Thursdays at Tampines at 5:30. Okay, where will I send the answer? I will upload it onto the same drive. Okay, if you do not have the drive, you can ask the admin, the Overmark admin, where the drive is. Okay, if not, let me just send the drive in the chat right now, just in case. Okay. Okay, if you divide the degree in 2 to degree in detail, then the degree in detail does not meet the range. Do we reject or keep it? Good question. The degree in detail will always fit. Always. It will only not fit if your previous range did not account for it, but it will always fit. So for example, for this question, right? Okay, for this question, if 2 detail fit the range, when you divide already, your detail will fit the range. Confirm will fit one. It will never not fit. Make sense? So as long as you start correctly, you make the correct adjustments. If it fits this range, after you go backwards, it will also fit. It will not fit. Yeah. Can? That's a very good question. I've not heard it before. Okay? Okay, if not, I thank you all so much for attending today. Okay. I hope that you all learned something. Okay. Please let me know if there's any feedback you have for me. All right. Okay. If there are any of my students, you can always stay back and say hi before I start my next class. Yep. Okay. Thank you so much. Bye bye.